Find the area ratio of green square to red square from the given figure. Trigonometric identities, Pythagoras' theorem, basic arithmetic and algebraic processes are used to solve this question. Label points C, M, D, E, F, K, J, L and G. Interior angles of equilateral triangle, each equals to 60 degrees. Join line D, G. Let the side length of the equilateral triangle be 2 units. Also, let the length of the green square be x. From right angle triangle G, D, E. Using Pythagoras' theorem, the square of G, D equals the square of E, G minus the square of DE, which equals the square of 2 minus the square of 1. The result equals 3. Take the square root of the equation. Hence, line G, D equals the square root of 3. This implies that line G, J equals line G, D minus line D, J, which equals the square root of 3 minus x. From right angle triangle G, D, E. Using trigonometric identity, line G, J divided by line J, L equals the square root of 3 minus x. All divided by line J, L, which equals to tan 60 degrees. Cross multiply. This implies that line J, L equals the square root of 3 minus x, all divided by the square root of 3. Line J, L equals line K, J, which equals square root of 3 minus x, all divided by the square root of 3. It is because line D, G is a line bisector of line K, L. Also, line K, J equals line D, M, square root of 3 minus x, all divided by the square root of 3. This is because opposite side of a rectangle are equal. Line C, M equals line C, D minus line D, M, which equals x divided by the square root of 3. Hence, area ratio, that is, area of green square to area of red square equals the square of x to square of, in bracket, x divided by the square root, equals 3 to 1. Therefore, green to red area ratio equals 3 is to 1.